How can you find the greatest common factor? Think about this question during the lesson. A pet store has goldfish and angelfish that have to be put into the fewest number of glass containers. Each container must contain the same number of fish, and each must contain all goldfish or all angelfish. Knowing the divisibility rules, are 20 and 30 prime or composite numbers?
Which one?
Why?
Liz, how do you know? Very good, very good. Remember, a prime number has only two factors, one and itself, okay? Composite has more than two factors.
20 and 30 are composite numbers because all numbers ending in 0 are divisible by 2, 5, and 10, and may have other factors. Find the greatest common factor of 20 and 30 to find the greatest number of fish that can be put into each container.
Again, GCF stands for greatest common factor. So sometimes in your textbook, you may only see it listed as GCF. That's what it means.
If a number is a factor of two numbers, it is called a common factor.
It's the factor they both have in common. Makes sense, right?
The greatest common factor of two numbers is the greatest number that is a factor of both numbers. How are the definitions of a common factor and a greatest common factor similar?
Both of them are common factors, except the greatest common factor is the largest factor that both of them have in common.
A common factor and greatest common factor are both factors of two numbers. How are these definitions different? A common factor might not be the greatest common factor.
Okay, listen to that again. A common factor may not be the greatest common factor, because just because they have a factor that's in common, there could be one that's larger than that, a factor that they have in common that's larger. But it can be, okay?
To find the greatest common factor of 20 and 30, you can list all the factors of each number and circle all the common factors. What are the common factors of 20 and 30?
So here we have 20. They made a list of all the factors of 20. 1, 2, 4, 5, 10, and then 20. They made a list of all the factors of 30. And so what are the common factors of 20 and 30, Alex?
1, 2, 5, and 10.
1, 2, 5, and 10. All those are common factors. You would list all those numbers if it wants to know common factors.
1, 2, 5, and 10 are common factors of 20 and 30. What is the greatest of the common factors of 20 and 30?
The greatest, Alex, is 10.
The greatest common factor of 20 and 30 is 10. Since the greatest common factor of 20 and 30 is 10, the store can put 10 fish in each container. You can now distinguish between common factor and greatest common factor, as well as find the greatest common factor for a problem.
On page 232 in your textbook, there are two different ways to find common factors and greatest common factors. One is the way that we saw in the first example on the video, and it's just to make a list of the factors. So if we need to find the greatest common factor, so GCF of 24 and 18, one way to do that is to write the factors of 24, make a list, and make a list of the factors of 18. So let's do that. The numbers that go into 24: 1, 2, 3, 4, 5 does not, does, because 6 times 4. 7 does not. 8 does. 9 does not. 10 does not. 11 does not. 12 does. And that's it until you get to 24. Those are all the factors of 24. All the numbers that can be multiplied to equal 24. Now we'll do the same for 18. 1, 2, 3, no 4, no 5, 6, no 7, no 8, 9, and then that's it until we get to 18. And so it has several common factors. 1 common factors, 2 common factors, 3 common factors, 6 common factors. 8 is not. Yeah. The greatest common factor is 6. That's one way to do it. It's up to you how you choose to do it. Another way to do it is to use the prime factorization, the factor tree. You learned how to do this, I believe it was last chapter, or maybe the chapter before, in math. So just a reminder of how to do the factor tree. We start out with the numbers 24 and 18. I need to think of a fact that multiplies to be 24. You're saying there are a lot of facts that multiply to be 24. Does it matter which one we choose?
Nope.
No. We get the same numbers at the end, the same prime numbers at the end? Yes. So Brody, give me a fact.
2 and 12.
2 and 12. Okay. 2 is prime. 12 is not. There are many numbers. I can multiply 3 and 4, 2 and 6. Does it matter? No. What do you want to do, Abby?
11. No, 11's not.
That's okay. What's a fact that multiplies to, no, what's a fact that multiplies to be 12? 3 and 4. 2 is prime, 3 is prime, 4 is not, that's 2 and 2. Now I'm left with my prime numbers. 2, 3, 2, 2. Done there. I'm going to go over to 18. I can choose 6 and 3. I can choose 9 and 2. Doesn't matter. I'm going to choose 9 and 2. 9 times 2 is 18. 2 is a prime number. It's not going to be broken down anymore, but 9 can. 3 times 3. Now I'm left with primes for each of them. Here's the thing to remember when you do it this way, guys. I like to do it this way. It's up to you. The thing to remember is, for 24, I'm going to list my factors from least to greatest. 2, 2, 2, 3. 2 times 2 times 2 times 3. For 18, it was 2 times 3 times 3. So what I have to do now is I have to look. When you do it this way, you have to say, what are the common factors in both of them? Well, they both have a 2, and they both have a 3. You have to multiply those common factors together. So I have to say 2 times 3 equals 6. So 6 is the GCF. That's the step that is different. When you make the list of factors, you just find the largest one. But when you choose prime factorization by doing a factor tree, then you need to find the ones, the pairs they have in common. 2 and 3 are both factors. Multiply them together to get the greatest common factor.